What if the Earth wasn't a spinning globe, but a flat, stationary disk? Imagine waking up to a world where everything you thought you knew about our planet was wrong. This idea, though it sounds wild, has fascinated people for centuries, and still sparks debate today. Let's set aside what we know and imagine. What would a flat Earth actually mean for our daily lives, sunrise, gravity, even the horizon? This isn't about proving or disproving, but about exploring how the shape of our world shapes everything else. If Earth were flat, it would rewrite the rules of physics, astronomy, and even our maps. So, let's dive in and see just how different and strange our world would be if it were flat. Prepare to have your perspective shifted as we explore the science, the myths, and the wild implications of a flat Earth. For millennia, humans have looked up at the sky, using the sun, moon, and stars as our first calendars and maps. Ancient thinkers like Aristotle noticed ships disappearing hull first over the horizon, and the Earth's curved shadow on the moon, early clues that our planet is round. Today, we know Earth is the third planet from the sun, spinning in a vast universe. This understanding explains time zones, seasons, and even how GPS works. Our round Earth isn't just a fact, it's the foundation for modern science and technology. The journey from myth to evidence-based knowledge is a triumph of human curiosity. Every time we use a map, check the time, or fly across the globe, we're relying on this hard-won understanding. The story of our spherical Earth is a testament to our ability to question, observe, and discover. So, what does the flat Earth model actually look like? Picture a massive, flat disk with the North Pole at the center and continents arranged around it, like slices of pizza. There's no South Pole. Instead, a giant ice wall, Antarctica, rings the edge, holding in the oceans. The sun and moon are imagined as small, close spotlights circling above, creating day and night as they move. Some versions even place a dome, or firmament, over the disk, with stars fixed above. In this worldview, Earth is central, contained, and unique, a cosmic terrarium. It's a model that feels intuitive from ground level, but it's a radical departure from the globe. This vision reimagines everything: our maps, our place in the universe, and even the laws of nature. But how would this world actually work? Gravity is the first big problem for a flat Earth. On a globe, gravity pulls everything toward the center, so down is always toward your feet. On a flat disk, gravity would pull toward the center of the disk, not straight down. Near the edge, you'd feel a sideways pull. Trees and buildings would lean inward, and walking would feel like climbing a hill. Oceans would pool in the center, leaving the edges dry and barren. The atmosphere would be thickest in the middle and thin out toward the rim, making the outer world airless and uninhabitable. The elegant balance of gravity on a sphere simply falls apart on a disk. Life as we know it would be impossible. On a flat Earth, the sun is a small spotlight circling above the disk, but if the sun never dips below the edge, there's no true night. Just a distant, dim sun always visible. Sunsets and sunrises with their beautiful colors wouldn't exist. The sun would just fade as it moves away. The sky's blue color and the red of sunsets rely on the sun's angle through the atmosphere, impossible on a flat disk. A small, close sun would light the whole disk at once, making day and night indistinguishable. The simple rotation of a globe explains our daily cycle perfectly. The flat model can't. The rhythms of life, sleep, activity, even the behavior of animals, would be thrown into chaos. The flat Earth model struggles to explain the most basic, observable facts of our days and nights. Seasons on Earth are caused by our planet's tilt as it orbits the sun. On a flat disk, with no tilt and a sun circling above, there's no way to explain why it's summer in Australia when it's winter in Europe. The flat model can't account for opposite seasons or the global patterns of weather and agriculture. Time zones also vanish. If the sun is always above, it should be the same time everywhere. Our system of local time, sunrise and sunset would make no sense. Even air travel exposes the flaws. Flights in the southern hemisphere, like Sydney to Santiago, are only possible on a globe. The routes airlines fly every day simply don't work on a flat map. The globe explains our seasons, time, and travel. The flat Earth can't. Today we don't have to guess the shape of our planet, we've seen it from space. Satellites, astronauts, and live feeds from the International Space Station all show a round Earth. The famous blue marble photo and real-time satellite images are direct visual proof. GPS relies on satellites orbiting a sphere. The system wouldn't work on a flat disk. The evidence is everywhere: curved horizons, time zones, seasons, airplane routes, and lunar eclipses. All these independent lines of evidence fit perfectly with a globe. To believe in a flat Earth, you'd have to reject the entire framework of modern science and technology. The round Earth isn't just a theory, it's a reality confirmed from every angle. So, why does the flat Earth idea survive despite overwhelming evidence? It's less about science and more about psychology, mistrust of authority, the appeal of conspiracy, and the power of online communities. The internet connects believers, creating echo chambers where misinformation spreads unchecked. Personal observation also plays a role. The world looks flat, and we don't feel it spinning. The flat Earth model feels simple and intuitive, even if it's wrong. It's a reminder that our senses can be deceiving, and that science often asks us to look beyond what seems obvious. The persistence of the myth shows the challenge of communicating science in a complex world. Exploring the what-if of a flat Earth isn't pointless. It's a powerful way to learn. By questioning, we move beyond memorizing facts and start understanding why things work. Science thrives on curiosity and skepticism. Every breakthrough began with someone daring to ask what if. The flat Earth debate is a case study in critical thinking, testing evidence, spotting fallacies, and building knowledge. It teaches us to check sources and think for ourselves, skills we need in today's world. Wonder and curiosity drive discovery, even down strange paths. The search for truth is a journey, and every question, no matter how odd, brings us closer to understanding our world. Subscribe for more science, space, and mystery content. Like, comment, turn on notifications.